also understand, why there is a mad rush, why there is a scramble for DevOps engineers today, and we are going to be getting testimonies of our class 24 that are graduating today. We'll have a few testimony from them. The truth is we can't take everybody on testimony because this course again remains 100% job guarantee training, which implies if you go through the program, and work on the projects, then of course you should be able not only to have a job, like to have jobs. I always tell students there are two options you have in this program. Option one is a job, option two is jobs. And today, amongst the people who will be testifying, we have one of our students who is graduating today who have already been able to secure 3 job offers. And this is somebody from a mechanic, to a DevOps engineer with multiple job offers. And today, again, we are going to have a lot of folks graduating, people with background, like from, pharmacists, we have nurses, accountants, chartered accountants, drivers, factory workers, and just to name a few, PSW, CNAs. These are people who have decided, to embrace a career in IT. And of course, it's possible to do that. You can embrace a career in IT and succeed with it from end to end. So these are the few stuff that I want us to take specific note of as far as this program itself is concerned, today. So that said, we are going to have phase 1 is a demo. Phase 2 again, we are going to be taking testimonies, and the final phase is going to be a Thanksgiving phase. We'll be thanking God for the class that is finishing, and also thanking God for the class that is starting. And we are going to be thanking God because, of course, we are sure that all of you that are starting today, the same way others are giving their testimonies, you too will be testifying. We don't care where your background is, or which kind of background that you have had in the past, but we trust God that, with His help and with diligence that you are going to be investing in this program, you will all leave this program not only rejoicing, but becoming the next IT engineer that the world is going to celebrate. So that said, I would just like us to pray as we get into this phase 1 of our DevOps end-to-end demo session. So let's just bow down our head. Heavenly Father, we thank you, Lord, for this morning. We bless you, Lord, for everyone that has come this morning, Lord, with a deep desire to have a change in their career. Lord, we thank you because it is even you that says in your word, you says you are going to do a new thing, which therefore implies embracing a new thing, embracing a new career, Lord. It is in line with your will. For you, speaking in your word, you said you, God, will do a new thing. Lord, I therefore pray that let this new desire that is in the heart of your people, they are all pregnant, Lord, not only to see that we have done IT, but to be able to contribute significantly in the world of IT, to be able to have a job, Lord, and be effective, Lord, and be productive in those tasks. Lord, I therefore cover every student with your blood, and I pray and I commit this class into your hands. Lord, I pray that you have your way and let your will alone be done in our lives. Let God alone be exalted in our midst this morning. For all those who will be testifying, Lord, we return all the glory to you, for we have seen you doing wondrous things, oh God, in Landmark. Students have been healed, Lord. We have seen people healed of tumor. We have seen a lot of things taking place in our midst. Lord, we say thank you. This is the Lord's doing. It is marvelous in our sight. We are humble, Lord. Take all the glory. Be exalted. Be magnified. In the name of Jesus. Amen. So, I hope you guys can hear me, everybody.
Yeah. Yes, Prof, you can hear you.
Okay, very good. Very good. So I'm going to be taking you guys now through the DevOps end-to-end demo, what DevOps is all about, and why there is a mad rush as far as DevOps engineers are concerned. Why is everybody, scrambling to get a DevOps engineer in their organization? So that's one thing that we are going to be able to look at in the next few minutes. what is DevOps, you know, and why should I be a DevOps engineer at this time of the year. So I'll be sharing my screen as well so that you can have
So what about the recording?
Yeah, at the moment we are on record already. Can you see my screen?
Yeah, Prof. Yes.
Okay.
Yes, Prof.
Yeah, we can
We
see
see your screen.
Very good. Okay, so this morning we want to look at a simple project. We are going to go through this stuff by looking at a simple project where you have a you own your company. So for the meantime, I'll mute everybody so that you'll not be able to unmute yourself for the next probably 40 minutes in this first phase of our presentation. Okay, now let's assume that this is you have started a new job, and that new job you are working in Landmark software solution. Okay, you are working in Landmark in your new career. This is you working in Landmark. Landmark is an IT company. So what is our business? We are developing softwares. So now I want us to see how, you know, all of this is going to evolve. So this is Landmark. Landmark has a customer, and this time around, this customer, this client, we have a client, and our client is PayPal. PayPal is our client. Now, what does PayPal want from us? What PayPal desires that we do for them is to develop a software. So this is Landmark software solution. Landmark SS software solution. They want us to develop a software for them. Now, there are different ways that you can achieve that task. The first method to achieve it is what we call the waterfall method. This is what used to be there before, the traditional waterfall method. So we want to do this, you know, project for PayPal. Now, PayPal is the client. So PayPal wants us to develop, okay, a software for them. And what is the purpose of that software? The purpose of that software is to permit their customers to be able to access their account online, you know, and do business. This is PayPal. This is the client. As you can see, this is the client. Now, so we have Landmark software solution. We have been tasked to develop an application for PayPal. So now, this is what is going to happen in, okay, normally. So what happens is that when we receive this tax from PayPal, okay, now, you know, in Landmark, we are going to understand the kind of tax that they want us to do. So how are we going to understand that? We are going to gather requirements from the customer or from the client. So requirements gathering. So a meeting is going to be held with PayPal. And now, who are those that are going to be in this meeting? In Landmark, our architects, you see that our architect, we are going to have architects and team lead. So like, you know, managers and stuff. And of course, today, DevOps engineers are part of that list. So now the architect will have a meeting with PayPal, the client. And what is going to be the outcome of that meeting? The requirements of this project is going to be put together. So this is what is going to happen, you know, as initiation. Yes, you want me to do a job for you. What is it that you want? All of that is going to be put together. So now, once we have this part of the task done with, you see that once we have this done with, the next thing that we are going to see, okay, after requirements are gathered, what is going to happen next? Now take note that this requirement is gathered by team leads, you know, in Landmark, and our architects. They're going to have a meeting with the client, Landmark and the client. A meeting is held. Now, once this meeting takes place, okay, the next thing is that in Landmark, we are going to be doing design. There's going to be a design. Okay, now we are going to have a designing stage. What happens in this designing stage? In this designing stage, we are going to be able to come out with, okay, this is what the client wants. All of that is going to be documented. So we have what we call high-level documentation. High-level documentation. And this high-level documentation, okay, will still be managed by team lead. Now, not just the high-level documentation. What do we need? What are we going to require to carry out these tasks for PayPal? Now, we need to document it. What kind of systems do we need? So we have system requirement. And all of this, again, we are going to have our team lead involved. You see that? The team lead are going to be involved in this stage. So in the designing stage, okay, what are we doing? We have to come up with what is needed for this project. All of that is documented. Now, once we document all what is needed to be done, the next thing is that we are going to get members of our team to get to work. And the next phase is going to be what we call implementation. So now they need to implement whatever the client wants. So we get into implementation. Implementation. So this is the implementation stage. Now take note that the task we have for this client, okay, is to develop, you see that, a software solution. So at the level of implementation stage, this is the time that we are going to get our developers involved. So now developers, this is the time for developers to get to work. So at the level of implementations, developers are going to be doing what we call, they are going to be writing code. So this is the task of developers. Now, once all of this has been accomplished, you see that the next stage of this project is going to be testing. Now, after this code is written, we need to get into a stage in the testing stage. Now, this is testing. At the level of the testing, whatever was done here, we are, okay, the QA guys, quality assurance team will run a test to make sure that everything that was expected has been delivered, okay, or has been, you know, implemented. Our developers have developed as expected. So this is the testing stage. Now, after this product is tested, you see that, oh, after the software is tested, what are we going to be doing next? Now, what we are going to be doing next is very important. The next thing we are going to be doing is deployment. And when we talk about deployment stage, okay, is taking the software or the product to the market. So now we have deployment. This is deployment stage. So in this stage, the product or software is taken to the market. And now, who are those involved in this stage? In this stage, we are going to have middleware admin. Middleware admins will be involved in this stage. So take note. So these are the guys that are in charge of deployment. Okay, now, this application needs to be deployed. So we have middleware admin. Okay, they are the ones that are involved in this stage. middleware admins. Now, once we have this application deployed, which means that it has been taken to the market. Like, for example, this is a market product for PayPal. Therefore, I can sign into my account here. Whatever I want to do, okay, I can do all of those. You see that this is a market product now for PayPal. So which therefore implies this is the implementation stage. You see that this is implementation stage. This is PayPal. Clients can log in, whatever they want to do, they are able to do that. But now look at something. When this application is running, something could go wrong and this website is not available. What happens? There's going to be a problem. The customers of PayPal are going to be complaining. Our applications, okay, we cannot access the application. I can't access my account. I can't do stuff. That is a problem. So how do we resolve this in this project delivery phases? Now, we are going to have a phase where we call support phase. Now, we are going to have support. In this support phase is all about maintenance or monitoring. So we have a maintenance stage. And this maintenance stage is all about supporting this application and ensuring that it is available at all times. So we are going to have our support team. So we have a support team, okay, who will ensure that this application is available at all times. So now, these are the different stages which you need to take specific note of when it comes to software delivery using what we call the waterfall model. You see that? The waterfall methodology. Okay. The waterfall methodology. Now, this is the stage that we have. So if you were going to use the waterfall approach of accomplishing a project, this is how you are going to accomplish that project. And now, if you use this kind of an approach, what is the problem here? Look at something. Remember that we have different members of the team. Now, when we use this method for project management, the problem here is that, okay, our resource utilization, okay, resource utilization is poor. So now, resource utilization using this approach is very poor. You see that? It's poor. Why? Because now, look at something. When our team lead are gathering requirements for this project, developers are doing nothing. You see that? So the developers guys, okay, like for like 2 months, they could have no job in the team. The QA guys equally are waiting for developers to develop before they can do testing. The middleware guys are waiting for everything to be tested and approved before they can deploy it. You see that? And the maintenance guys can only start, okay, monitoring, you see that, and supporting this application, okay, when everything has been done. So the first problem here is that resource utilization, okay, is poor. Now, the second problem here, which we can observe, is that if there is a problem in, okay, any of this stage, it affects the entire stage. So you have to go back and start what? Designing. So that is equally one of the drawbacks of this approach. Now, one more approach is, okay, one more drawback is time. You see that it is time consuming. It consumes so much time. You see that? Take note about that. Now, this approach can take like 6 months at times. Okay, it could take like 6 months for a software to be delivered. In the world that we live today, everything is going very fast. So this is the problem with the waterfall approach. Now, because of this problem, okay, companies have come up with what is commonly used today. You see that? And this is what we are going to be looking at next. And this new approach gets to do with the agile, okay, agile project management, agile methodology, how you can use the agile approach for your projects. We have seen the limitation, if we're going to use the waterfall approach. So how can we use the agile approach? Now, still, we have the same project that we are trying to achieve, the same client paper. Now, if you are going to use this agile approach, one thing that we are going to be trying to achieve here is that now we are going to use, the Scrum method, for example. So in this approach, let's look at Scrum. So we are going to use Scrum. Now, if you are going to use Scrum, you see that Scrum is one of the agile approaches that we can use when it comes to project what? Project management. And we call that agile project, management. Now, in this approach, what happens is that you have a project from your client. And that project, now, the project with paper, for example, we are going to sit down and find out now how much or how many features is this project going to be needed. So let's assume that this project is going to need 50 features. You see that? Because we want to develop this application for paper. And this application requires 50 features. This is the application for paper that we are trying to develop. We have the feature for dashboard, for pay and get paid, wallet, activity, invoicing and stuff. We have a lot of features that we want to deliver for our client. Now, we want to use, the Scrum, approach to achieve these tasks. Now, when it comes to Scrum, what happens is that now we are going to come out with, different iterations or what we call sprint. Now, we have different sprint. So if we have different sprint, for example, you can have sprint 1. Now, sprint 1, sprint 2, sprint 3. Now.
If I'm just want to be next to you.
We have stuff like this. Now, please make sure you mute yourself, please. Mute yourself, very important. Now we have the first sprint. We have the third sprint. Now we have the fourth sprint, something like this. Just an illustration. Now look at something. This is the project. Now this sprint represents, a production period, for example, or a development period. So now we have 50 features which we want to be able to deliver to our client. Now we are using agile project management with Scrum. Now, in this sprint, so we have sprint like this. As you can see, we have sprint like this. Now, look at something. A sprint, most of the time, a sprint is going to last for a number of days. So we can have a sprint. Let me come here. So, we can have a sprint, that runs for 10 working days. So we have each sprint is going to run for 10 working days, which definitely implies that in the 50 features that we are developing for paper, we are going to distribute these features depending on how many of the features we can be able to deliver for each of the sprint. So now, based on that, we will need to identify the resources that we have. What are our resources? Let's assume that when it comes to our resources, I want to illustrate something. For resources, we have 4 developers. For resources, 4 developers. What else do we have? Now, we have one middleware admin who is going to do the deployment. We have one middleware admin. We have one middleware admin. These are the members of our team. Now, we have the QA guys, somebody who is going to check that everything is okay. Now, and we have a project manager, which in this case is going to be called a Scrum Master, because that's an Agile, okay, project manager. Now, we have a Scrum Master. These are the members of our team. So we have a team of 7. 1, 2, 3, 4, 5, 6, 7. So we are deciding how many features we are going to be able to deliver based on the resources that we have at our disposal. And take note, these are the resources that we have at our disposal. This is what we have. These are our resources. We have 4 developers, 1 middleware admin, 1 person for quality assurance, and we have, an Agile project manager. Now, we decide that, okay, for us to carry out this entire project, we are going to need about maybe 10 different sprints. And it will be 10 different sprints of 10 working days each, which is 2 weeks. And for each sprint, we are going to be developing 5 features. So which therefore implies we have 5 features for each sprint. Now, so we have 5 features. Take note. And take note that these 5 features, we are going to be involving, okay, our resources. These are the resources that we have. So developers are going to be developing now, which therefore implies every 2 weeks, we are sure that 5 features, okay, is going to be developed, fully tested, okay, and if everything is okay, we are going to click on done. So this is what we have. But now, if for some reason in sprint 1, okay, everybody is involved. Now, if you look at, okay, what we have here in terms of the Agile project, okay, management, the team velocity is very high, which implies all the members of the team must be involved. So the team velocity is high. But now, if something happens, okay, in sprint 2, and we did not have all our developers, let's assume we had just 3 developers. Now, therefore, in sprint 2, okay, we realize we cannot develop 5 features. We can only develop 3 features, for example. Why? Because the number of developers, okay, all of them are not on board. If you look at this Agile approach again, now the problem here is the team velocity is high. All the team members, they need to be on ground. You see that for us to be able to accomplish our tasks. Now, in addition to all of this, we have different meetings. Like we have what we call daily stand-up meetings. You see that where, members of the team will be present in a 15-minute meeting to discuss on what they did the day before. And if they had any problems, what we call bottlenecks, now the Scrum Master will take note of those and try to see how to remove those bottlenecks or impediments for members of the team to carry out their project with relative ease. So this approach that you see here, okay, now companies are still implementing the Agile, okay, approach in conjunction with the DevOps methodology, which is what we are going to be looking at shortly from now. So we are going to have meetings in this approach. Like, as we said again, we have what we call daily stand-up meetings. You see that we have daily stand-up meetings for the meetings that you should take note of when it comes to this approach. Okay, we are going to have stuff like daily stand-up, daily stand-up meetings. What else do we have? We have the planning meeting, what they call sprint planning. Sprint planning. These are just some important meetings that I'll just show some light on them. Now, we also have what we call okay, sprint retrospect. Sprint retrospect. Now, retrospect. This is like a review meeting. So at the beginning of each sprint, we are going to have a planning meeting. And we are going to plan. In this meeting, members of the team will agree that this is what we want to do in this particular period. So in this production period of 10 working days, our target is to be able to develop 5 features of this application and deploy it to our client. So this is how all of that is going to be managed. And now, what you should take note is that when it comes to the customer, which is PayPal, PayPal is our client. Very important. Now, what should you understand about PayPal? Take note that PayPal is going to have, in PayPal, PayPal has their business analysis, okay, their business analyst. Business analyst. You see that they are BA guys. So in PayPal, they have their BA guys. So what happens is that whenever we are done, okay, with each of the sprint, now the business analyst of PayPal, which is our client, they will review what we did. Yes, we are happy with that. And if they are glad with that, okay, they are going to click on done, which therefore implies the features which we have developed in that sprint, they are satisfied, the client is satisfied. And that satisfaction, the people we are going to be communicating with will be the business analyst of PayPal, the client. But take note that in this whole project delivery, what do you realize? We, at the beginning in Landmark Software Solutions or Landmark Tech, what do? We have a meeting and we agree that for the next 10 working days, this is what we are developing 5 features for our PayPal client. Now, at the end of the sprint, we are going to have a retrospect meeting to ask ourselves questions like, now, what did we achieve in this sprint? Now, what is it that we could have done better? And how can, and how can we improve? What have we learned in this sprint? And how can we improve on what we have learned in the next, okay, production period or in the next sprint? And but daily, we have follow-up meetings. So please take note, it is very important. The Agile approach, again, is a very useful approach. But now, today, we have gone beyond Agile. We now implement Agile plus DevOps. So we are going to look at DevOps. Okay, what is DevOps all about? And why should I know DevOps? And how does DevOps fit into all of this? So now we want to look at DevOps. DevOps. This is what we want to look at. What is DevOps? How does it fit? And why you should be doing DevOps. This is what we are going to be looking at now, the DevOps approach. Now, remember, this is Landmark Software Solution we are talking about. So we have Landmark Software Solution, managing a project, LSS, Landmark Software Solution, managing a project for her client. And this client is PayPal. We want to use DevOps. You see that? And why are we going to be using DevOps? Why is everybody using DevOps today? And why should you recommend DevOps? Okay, if you were working in an environment where DevOps is not yet being implemented or the DevOps practices. Now take note that DevOps is not a tool, but DevOps is a methodology. Like one of our students went to an interview and they asked her, tell us, what is DevOps to you? Because if you understand DevOps today, you can explain it how you have understood it. Now, the question was not what is DevOps? They said, thanks again for coming for this interview. Please, question number 1, what is DevOps to you? That was the question. And she said to her, DevOps is a process of continuous transformation, continuous improvement. That is, DevOps is you using automation to continuously improve of your tasks, processes, and the process of software delivery. Because all of this that we have looked at today is the process of software development. Like, you know, in software development life cycle, this is how it looks like. We have different approaches. Okay, the waterfall approach. We have seen the agile approach, and now we have to look at the DevOps approach. Now, look at something. We have a client called PayPal. So immediately landmark, okay, have this customer called PayPal. What are we going to do? Now, we are going to start the process of developing the application for the client. And in that process, okay, the first thing that is going to be done is that now we are going to create what we call a repository for PayPal, our client. So our client is PayPal. Now we are creating a project repository for this client. Now this project repository is going to be created in Git. Okay, now this is what is being achieved. So once we create these repositories, we have developers. Let's assume that in this project, we have our 4 developers who are going to be developing for PayPal. 4 developers. So now let's look at what is their function. So developers are going to be writing code. They are doing implementation. So they are writing code for our PayPal client. Now, when developers write this code, okay, these are the developers that we have. Developers are coding. So now, look at something, please. When they write the code, what do we expect them to do? This is landmark software solution, and we are looking at the DevOps methodology when it comes to, you know, why companies are implementing, okay, DevOps processes in the organization. Now, this is PayPal. So in this process, our developers will be writing code and they will be committing the code in GitHub, in Git. So this is where the code is committed. So all these developers, okay, they are going to be achieving the same tasks. So we use, okay, Git for what we call versioning. That is why we are using Git. So Git is used for versioning. So we have something like this. Now look at something, please. So developers are writing code for our client and they are committing this code, okay, using Git to Git, let me put / GitHub. So this is what is happening for our client. Now, but look at something. If you realize GitHub, okay, is what it, therefore GitHub is what we are using to manage the code for PayPal, to manage the softwares that our developers are writing. So we are using, okay, Git to get, okay, to achieve what we call the different versions of the code, and we use GitHub for our source code management. But now, as a DevOps engineer, developers are the one writing the code. What is my function? My function is to create this repository in GitHub. So I am going to create this, okay, I create a repository where developers can commit their code. So once I have done that, the question is, what would developers be committing? So take note, let me show you. Developers will be writing code. Okay, I will represent it as SRC. So developers write code. Now, take note, developers are writing code. Okay, now, but for developers to effectively manage their job, when they write code, they need to test it. So they will write code plus what we call test cases. So they need to write the test cases or unit test cases. Take note about that. They write unit test cases. So developers are writing code and they are writing unit test cases. This is what developers will write. Now, therefore, what gets into GitHub is code plus unit plus the test cases that developers had written. You see that? Why? Because if you write code, you need to test the code and make sure that it is working as expected. So this is what happens in real time. So developers write the code and they equally write the test cases. So what gets into our code repository here is the code developers had written plus the test cases. But there is something very interesting. Now look at something. When developers write this code, for example, okay, in Landmark, we are managing what we call Java projects. So our developers are writing code in Java. So they can write a code like, app.java for the application we are trying to deploy. They have written a code called app.java. Now, all these developers are committing the code to GitHub. And one of the good things about GitHub is that now GitHub gives a platform where these developers can easily collaborate. Therefore, if developer one was working on this app.java, now where he or she ends, developer two can just proceed from there. Therefore, GitHub helps you not to be, that is, it helps you, to ensure that you don't repeat the tasks that others have done. And one other thing that Git does is that it helps to track the different versions of the code. So it helps us for versioning. But now look at something, please. When these developers are writing this code, now the destination of this code is going to our client. Now, this is our client here, paper. So in paper, now this application needs to be running in some paper servers. You see that? It needs to be running their servers. And for this application to run in their servers is very important. Now, look at something. Now, it is only when the application is running in paper servers that we can access it like this. Now, customers can get into their account and do whatever they want to do. But look at something very important. Now, in all of this process, what are we trying to achieve? Now, in the server, in our customer environment paper, we are going to be deploying this stuff in JBoss or Tomcat. Take note about that. JBoss or Tomcat servers. So this is the application server where the applications is running. So we call this, you see that, application server, app server. Take note about that, very important. App server. So this application is running in this application server in our client environment. Now, but look at something. One thing you will realize is that for this application to run in this server, it cannot run in the way developers have written it. So it is going to go through what we call a build process. So it needs to be transformed, in a form that this server, this application server, which is running either JBoss or Tomcat, will easily interpret it, will easily, display it in this nice fashion when you go to your account like this. So how do we achieve that process? For us to achieve that process, we need to do a build. And doing a build is going to depend on the kind of project you are managing. In Landmark, we are managing Java projects. And for you to build a Java project, you are going to use what we call Marvin. So we'll use Marvin to do a build. And when a build is done, that build is going to generate, some packages. Those packages, as you will come to realize, they are going to be jar packages, war packages, or ER packages. Now, this is for web and enterprise or standalone application that we are developing. So these are the packages that have been created. Now, you can either use Marvin. Some companies use AND. You see that? You can use Marvin, you can use AND. It all depends. But these are the packages that are created. Therefore, we are deploying these packages to our client. But for you to be able to do this build, there is one additional task that developers are going to do. Now, when developers write this code, they are going to write what we call a build script. You see that they are going to write a script that is going to be used to do the build. We call it build script. They are going to write a build script, which is very important. So developers are going to write build script. Take note. So they write build script in addition to the code they have written. You see that in addition to the unit test cases that they wrote. So please take note about that. So now, with the help of the build script, we can do a build using Maven. So now a build has been done. This build that has been done, it is now possible for us to deploy this build in our application server, because this build can now be understood and interpreted by our client application servers. But take note, there is something, because we are going to be managing applications that are very critical, like PayPal get to do with people's money. That is a financial organization, what we call fintech. You see that this is a fintech client. Because when you finish this course, you can work for fintech client. That is client in the financial industry. You see that PayPal is a fintech client now. This fintech client can be a bank, insurance company, whatever it is. So this is a very critical application. So what are we going to do? Now, before, we deploy this application, now we are going to make sure that we, first of all, we back it up such that if something happens, we can access it. So we are going to back this up in another tool called Nexus. So we are going to be using Nexus to back up the artifacts, because look at something, please. What Maven or ARM is going to create here are jar files, jar, wa, and here. We also call them artifacts. So you can call them packages, or we can call them artifacts. So these are the artifacts. So now, what comes into Nexus are these artifacts that you see here. So we are going to have these artifacts. Our artifacts are going to be backed up in Nexus. So before we get off to our customers, what are we going to do? We first of all create a backup. So now developers have written the code. They have pushed or they have committed the code in GitHub. We are going to use Maven to build. And when we use Maven, we create packages. We call those packages artifacts. Those packages need to be deployed to our customers. Now, before we deploy these packages to the customer, we create a backup in Nexus such that if something goes wrong with Maven, and Maven is no longer available, we know that we can get this stuff where it is backed up in Nexus. So please take note, it's important. But look at something. Now, before we even upload to Nexus, there is one additional thing that we need to do. We need to do what we call code quality. We need to review the job of developers. So how are we going to review that? We are going to use what we call SonarQube. We are going to be using SonarQube. Now, what does SonarQube do? It does code quality. It does code quality. So in Landmark, now, before our developers even start developing, we are going to give them a blueprint document where we are going to be telling them that in this project that you are going to be doing, you must make sure that, the quality of your job should be at least 95%, for example, because we are managing, critical applications that get to do with fintech client. We have clients like, in the health industry. You see that we don't want to take any chances. So for us to be able to, deploy this application, now we must make sure that the application we are, because deploy means you are taking it to the market. So if, for example, it was a vaccine, now it must go through testing. You see that whatever has been done, it must be tested. So before we take it to the market, before we take it to our customers, okay, there is one thing we want to achieve. Now, in Landmark, we have a blueprint document where we have defined, okay, for example, remember what we said here. When developers write code, they are expected to write unit test cases, which implies when they write a code, they need to test the code. For example, now, if they write a code where, okay, developers can, pay and get paid, they need to test it. You see that? Can somebody actually be paid? Can somebody actually get paid? That is what is happening. So that is what we are talking about in this process. So now, the kind of work that we want, the quality of tasks that we want to accomplish is going to be recorded in this, okay, document called SonarQube, which is a saver. Therefore, before we even upload the artifacts to Nexus, we must have run our code quality analysis report. And we need to be satisfied before we back it up. If it is not satisfactory, we are going to trash it and inform developers that the task you did, there is a problem, get it fixed. But if everything is okay, that is when it is now deployed, okay, to our, okay, that is when it is deployed to our client. But now look at something very important. Now, all of these bits and pieces that you have seen, now we are going to be able to look at a way that we can put all of this together. And we are going to use what we call, okay, an integrator. Now, we have an integrator, an automation tool. And this automation tool here is called Jenkins. So we are going to be using this tool to connect all of these bits and pieces together. Because if you look at this stuff here, you realize that we are, Git, we are going to commit code in Git. What are we going to do in Maven? We do a build. Nexus, we upload the artifacts. You see that? Upload artifacts. Okay, upload. We upload artifacts into Nexus. This is what is done. Artifacts are uploaded into Nexus. But now we need a tool that can connect all of this together. And that is where you come in as a DevOps engineer. So we are going to be using Jenkins as an integrator. And what Jenkins does is it does continuous integration and it does continuous deployment. So immediately developers commit any code to GitHub, this is what Jenkins is going to do. Jenkins is going to pull the code from GitHub. Now, look at what Jenkins does. Jenkins is going to pull this code from GitHub. Well, after Jenkins pull the code, Jenkins is going to connect with Maven to do a build. So now, this is what Jenkins is doing. Jenkins is connecting with Maven, and Jenkins is doing a build. Now, once Jenkins connect with Maven, so look at something, please. This is step one. Developers are committing the code to GitHub. This is step two. Jenkins is pulling the code from GitHub, as you can see here. Jenkins is pulling the code from GitHub. This is step three. Jenkins is doing a build with Maven. Take note, Jenkins is doing a build with Maven. Now, once Jenkins does a build, okay, before the artifacts are saved, are uploaded into Nexus, Jenkins is going to connect with this guy called SonarQube to check if this code to check if the code, okay, meet our quality threshold, our benchmark when it comes to quality. So this is how Jenkins is going to achieve that. Jenkins connect with this guy called SonarQube for code quality. Now, if everything is okay, this is step four. What is Jenkins going to do next? Jenkins will now upload the artifacts into Nexus. So the next stage is Jenkins will upload these artifacts into Nexus. So the artifacts is going to get to Nexus. This is what Jenkins does. And this is step five. So in step five, the artifacts are going to be uploaded into Nexus. Now, look at what happened. Once these artifacts are uploaded into Nexus, it means everything is okay. That is a time that Jenkins is now going to deploy these artifacts to our client. So it is deployed to the client application servers. So this is what is going to happen in real time. And now look at something, please. So Jenkins deploy this to our client application servers. But now, most of the time, Jenkins will not directly deploy to the client because we are going to have one additional tool which we are going to use. For example, let me show you something. Now, PayPal has millions of customers. They cannot use one server for all their customers. You have millions of customers. So since they have millions of customers, PayPal can have multiple application servers. You see that? PayPal is going to be having multiple app servers, like, multiple app servers. Take note. So PayPal has multiple app servers. These are the different application servers of PayPal. Now, watch what is happening. So we have, I'll just take this 3 for now. Now, look at something. So when PayPal got these multiple app servers, okay, the best way for Jenkins to do a deployment is that Jenkins is going to add one more tool. Jenkins is going to, okay, we are going to have one more tool on our CI/CD pipeline. And this is going to be Ansible, or we can use what we call, okay, we can go for Ansible, or we can go for Urban Code Deploy. So these are the options that we have. Ansible, Urban Code Deploy. Now, we have something like this. So whatever artifacts is going to be created is going to be shipped to Ansible, and Ansible will manage the deployment. With the help of Ansible, Ansible can deploy this stuff with one command to even 1,000 servers. So this is why you are hired. You are hired because you know Ansible. Okay, with the help of Ansible, you realize what Ansible will do. Ansible comes here, and Ansible is deploying this application with one command, okay, to thousands of servers at once, because we are using Ansible for deployment. Now, this is what is going to happen. But look at something. Your application is running. Your clients are happy. What are you supposed to do? Are you going to be coming to check every day if this application is available and running? You won't be able to do that. You can't do that. That is not practicable. So now we need to, how do we ensure these applications are up and running? How do we ensure that? You see that? How do we ensure that the applications are up and running? We are going to be using a monitoring tool. We use monitors. It's just like your child is sleeping. What do? You install, okay, something to be able to, watch that child. What is that? Monitors. You see that? So we are going to be able to use, okay, monitoring tools to achieve that, which is very important. And now, which are the monitoring tools that we can use? We are going to see different monitoring tools in this course that we are going to be doing, okay? But now, we have stuff like New Relic. You can use New Relic. You can use New Relic. What else can we use apart of New Relic? You are going to realize that apart of New Relic, we can use App Dynamic. Okay, we can use Nagios. These are, okay, monitoring tools. And we have this group of monitoring tools that can be used for this purpose. We even have more, which we are going to be doing in this course. But for the purpose of this illustration, I'll dwell on these 3. Now, what are these 2 achieving? This 2 is going to be achieving what we call continuous monitoring. So it monitors these application servers and make sure that the applications are running. You see that? It monitors all these application servers to make sure that the applications are what? Are running. It's monitoring the servers. You see that? It's monitoring the servers. So this is the purpose of these monitoring tools. It monitors our application. Is the application running? Okay, this is the purpose of the tool. That's why we are using monitoring tools like this to monitor the application. And if something goes wrong with this application, what this monitoring tools does is that, okay, it is going to alert us immediately that something is wrong. So it has an alerting system. And with that alerting system, we are going to have a support team. Okay, now we are going to have a team that is going to be doing support. Okay, so we have support and ticketing. So now, so if there is a problem, this guy is going to be immediately informed. You see that something is wrong, there is a problem. And the support guys will do what? They will create a ticket to get that problem fixed. Maybe they have to notify. Okay, so support and ticketing, which is very important. Wait a minute, what did I do? I took out this guy. Let me come back here. What you're supposed to do. Now, so we have here SonarQube for code quality. Something like that. So this is our support team. So our support team will ensure that, okay, if something went wrong, the tickets are issued. You see that? So tickets are issued. And so tickets are going to be issued. Like for ticket here, we are going to be using stuff like Jira. Okay, can use Service Now. It's an all option that you take note of. Then we have Jira. Okay, now tickets are going to be created. And once these tickets are created, you see that the members, the right team members are going to be contacted. So we are going to have ticket generated, and the team members that need to be contacted will be contacted. Okay, developers or our admin team, depending on where the problem is. So this is the end-to-end, okay, DevOps automation. Now, with this process, what are we able to achieve with this process? What we are able to achieve is that if you look at the Agile approach, now we need about 10 working days to be able to develop a feature of our application. You see that? Therefore, if we are going to have 10 different sprints, that is 50 working days, 50 weeks. So it still takes a lot of time. Now, with the DevOps approach, you will come to realize that with the help of this automated pipeline, okay, now, whenever developers develop a new version of the code and commit it to GitHub, immediately that is done, okay, now a new application is deployed, and that can take place in the next 2 hours. So which therefore implies in one day, we can even deploy like, 3 different versions of the applications. Whereas with the traditional approach, it took a lot of time. So this is what DevOps end-to-end automation is concerned. Now, there is also one thing I want to illustrate to you guys before, nowadays, we also have microservices. So with these microservices, how are we going to be deploying this application? How are we going to do that? Now, with the help of microservices, okay, deployment is going to take place not via Ansible like this, or even if we have Ansible, okay, we are going to be deploying this application in a Kubernetes cluster. That is, we are going to now have Ansible, okay, will deploy this application to Kubernetes. So we are going to have, let me take out these guys and illustrate. So we are going to have a Kubernetes cluster like this where, okay, Ansible, this deployment is going to be taking place in a Kubernetes cluster. You see that? So now we are going to have Kubernetes. So Kubernetes. So we are going to be doing Kubernetes and Docker in this course. Very important because nowadays companies are very heavy when it comes to microservices. And you are going to come to understand all of that. But now this is still with that, we'll still be monitoring the application. So with the help of Ansible, okay, we are going to use Ansible again to deploy this application to our Kubernetes cluster. And once it is deployed, we need to ensure that it is monitored. So this is the scenario where we are managing microservices. You see that? So this gets to do with microservices. Let me just microservices application. So if you have an application that is running on a microservice architecture, this is how we are going to deploy it using Kubernetes and Docker. So please take note, this is what we are going to be covering, okay, as far as this particular program is concerned. So take note, it's very important. This is DevOps end-to-end automation. This is what you needed to have a good understanding of. You see that? So now, what are some of the things I should let you guys know? We have explained already the traditional approach and all the approaches, and we have seen the end-to-end DevOps automation. Now, the big question is, okay, when we do this course, like some people have asked me, you know, how would the program be run? Now, this program is being run using, we have a lot of projects that we are going to run alongside this program. Like we have projects like this one. Our first project is just what we have explained, where we have Jenkins, SonarQube, we have Nexus, which is called Sonatype, we have Marvin, we have Tomcat. So in the course of the class, we are going to do projects like this where once developers commit code to GitHub, Jenkins is going to pull the code, Marvin is going to do a build, SonarQube will execute code, okay, code quality report, we'll upload our artifacts and we'll deploy the build to Tomcat, which means, our clients, okay, clients can access that particular application. Please take note, it's very important. So this is one more thing that I want to take specific note of. And here we have project 2. We'll see how we can do all of that, but deploying it to Docker. Okay, and we have project 3, how we are going to be bringing Ansible. Okay, and we are going to deploy that with Docker. So we also have project 4. You see that? The same scenario. We have project 5. So we have about 7 to 10 projects that we are going to do in this course. And if you go through this course and do all your projects, okay, you understand your projects, you are going to be, that is, you are going to be like someone who have at least 5 years of IT experience, because this is what folks are doing at work. Now, this is the syllabus of this program, what we are going to be covering from end to end. You see that this is what we are going to be able to cover. We'll start with Linux commands. You see that? We'll start with, okay, Linux. Linux is normally the first 3 weeks, so it's going to be 27 hours. We have share scripting 9 hours. GitHub is 9 hours. Okay, now we have Marvin. In our last class, I think Marvin was like 5 hours. Tomcat and JBoss also was about 4 hours. So this is how we are going to be able to cover all of this. We have SonarQube, Nexus, Jenkins. In our last class, Jenkins was 15 hours. Now, we have Docker. Docker is 18 hours. We have Kubernetes, 27 hours. So this is what we are going to be able to cover. Ansible is going to cover 12 hours. AWS Web Services, 12 hours. You see that? Now, we are going to equally do some GCP, and we'll look at monitoring, how to monitor our applications. And we'll equally look at Terraform, infrastructure as a code, for 12 hours. Very important. Monitoring as well will be like 6 hours, because we have to look at how do you monitor your applications. And there is one thing that we do, which is very unique to Landmark. We do interview preparations for all our students to help everybody, okay, to understand how to confront the interview, because we understand that 90% plus of our students are people that are going to be doing IT for the first time. We also help in resume lines. Once you are done with the course, how should your resume line looks like? Now we have read live project that is done at work, interview questions. So this is why you take specific note of as far as this particular course is concerned. And this class is going to be running. Okay, there is going to be no class tomorrow. The next class will be the first class that is going to be Linux is going to be on October 7th, which is Thursday next week. So we have October 7th to February 17th. So please take note, it's important. This is what you should expect as far as this program is concerned. So
February 7th, 2020, 2022 or 2021?
2022. Thank you so much for that observation to February 17, 2021. So this is what we are going to be covering.
How many phones do you have?
How many calls?
Oh, she got a new phone now, she.
What time?
Time. Let me see. I think the time should be. Let me check. Now, this is the class time. Once, if you have enrolled already, okay, you should have been sent this information. We should have sent this to you. Okay, class 26 onboarding details. If you have enrolled, you need to have this onboarding details. Congratulations and thanks for choosing Landmark Technologies 100% job guarantee DevOps with AWS and Linux Master Program. This is the schedule. Again, thank you so much. It's 2022. Okay. Now, this is the class schedule. Our next class is going to be on Thursday.
Yes, darling.
And it's Thursday.
I'm putting it in this. I'm putting it in the new phone.
Oh my goodness.
As you can see here, it's Thursday, 7 p.m. EST, which is New York time. Now, the next class is going to run on Saturday. You see that? 8 a.m. to 11 a.m. New York time. And Sundays, 3 to 6 p.m. Now, to make your learning easy, join the following channels and class groups. Now, join class 26 WhatsApp group. You need to be in this WhatsApp group, okay, because that's where we are going to be, be able to discuss as a class and share some other relevant information. The next thing you have to do, which is very important, is you need to install Telegram app on your phone and computer and join the class group and our 24/7 DevOps support hub decks. Now, we understand that 90% of our students are completely new in IT. For that reason, we have a hub desk that is running 24/7, which implies at any time, okay, you can be able to connect as far as all of this is concerned. You see that you can connect at any time. Let me see something, new participants. Okay, now, if you had a class and you were having, and that is if you were, because now, look at something, please. What is the function of this help desk here? This help desk, what does it do? If you look at, okay, if you look at the help desk, what the help desk does is that if you have a problem at any time of the day, it does not matter whether it is at midnight, 1 a.m., 3 a.m., or at midday, whenever you have a problem, go to our Telegram help desk. You see that, just go to the help desk and Telegram, somebody will help you, because we have made the classes such that, okay, for example, this is the help desk. You see that, here's the help desk. If you have any problem, just post the problem on this help desk. And like, for example, somebody had a problem, let me see, at 2:34 a.m. Can you see that? He says, as regards SonarCube, now he or she hosts a meeting, okay, and folks are joining him at that time. You see that that is two. Now look at something. Someone else had what issue at 1:35 a.m. this morning. Okay, so whenever you have a problem in this your journey, post the problem on the help desk. Just post your problem on the help desk, and you will have 500 engineers plus who are ready to help you. It's very important. And we equally have a desk for those that are working already. Okay, just those that are working. Now, once you get done as well, you are going to be moved in to that particular platform. What that does is that if you were at work and have a problem, you can just share it, and somebody in that group, okay, may have had the same experience in his or her own job. So with that, your problem can be easily resolved. So this is what this end-to-end program has been. And this is one thing you should take specific note of. So please, very, very important. Okay. Any question?
I have a question.
Yes, please.
Can I work from home if I finish the course? If I get a job, can I work from home? That's the most important thing for me.
If you get a job, So far, all our engineers are working from home 100%.
Okay,
Yes.
that's the most important thing for me.
Yeah, because part of the things we teach is cloud computing. Like I forgot to explain that. When you finish this course, you have like 7 jobs that you can do. The first one is a
Okay.
DevOps engineer. The second one is a cloud engineer, infrastructure engineer, platform engineer, site reliability engineer. You know, so what you can do, you have like 7 different jobs that you can do once you go through this particular program.
Okay.
Okay, you are welcome. Let me try to check this.
Yeah.
Some people
Hello,
are-
Prof. Hello,
Yes,
Prof.
please.
Yes, I have a quick question. So just to make sure, so tomorrow there's no class.
Very important. No class tomorrow.
Perfect.
There's no class
Yeah.
tomorrow.
Hi,
The
Prof.
first actual class is Thursday next week because we have to make sure that everybody's environment is set up. Everybody has joined all the groups expected. And, you know, the next class is going to be holding.
I have a question.
Yes, please.
Anyway, it's personal. Anyway, I'm over 60. How does that affect me getting a job?
It doesn't affect you. Our oldest student in the class is close to 70.
Okay,
Yes.
thank you.
You're welcome.
Yes, so, yes,
Prof.
I have a question too. I have
Yes,
a question. Yeah, I don't have the schedule already, the one you sent to everybody. I don't have it.
Okay, don't worry. You just ping me. I'm going to share that with you.
Okay.
Now I'm.
I have a question.
Hi,
Prof.
Prof.
Yes,
I have a
please.
question.
Yes, my
Yes, go
question
ahead.
is, yeah, how do you, if a student miss a class, how do they do a catch up? Because sometimes schedule can really be crazy, not that we don't want to, or we are not giving it priorities, but things can happen and you miss a class.
Okay.
How do you do have a catch up?
Okay, please. I want you guys to give me like some few minutes. I'm trying to troubleshoot because this meeting, some people are trying to join. Those are supposed to share testimony. I think we have a lot of people out of the class who are unable to join. Let me just find out what is just give me some few minutes.
And
Yes, we do. We are able to have that. Normally, when the class is going on, I mute everybody. Nobody can ask anything.
And when it's time to ask questions, can people just raise up their hands to ask questions instead of multiple people talking at the same time?
Yes, we have that equally in place. Mhm. We have that in place.
Question.
Hello.
Yes,
Prof,
please.
I have a question. Please, is
Yeah.
it possible to get a material on what was shared today, like the introduction? Can we
Yes,
get
you are
the
going to have the
material?
video after this class. We'll be sharing the video after this class.
Yeah, okay.
All right, thank you.
You're welcome.
Yeah, another question, sir.
Yes.
I just want to find out what is the minimum qualification for someone to